Hello, everyone. Welcome to another edition of Mr. Bahi's screen recordings. Um, so today we want to talk to you about finding determinants. Um, Here we go. These are determinants. So matrices have determinants, and I'm not going to go into too much detail about what they're used for, but there's so many applications to these, and you'll be doing them next year, especially. I know this for a fact. You will be doing them next year in pre-calc, um, pre-calc honors, especially. I'm not exactly sure what the regular pre-calc curriculum looks like, but you are going to be doing these in those classes when you learn about three-dimensional vectors, um, which is actually really cool stuff involving it describes physics in the world that we live in. But you will be doing determinants. They're called cross products when you're talking about three-dimensional vectors. But there's so many applications to them that most of these applications are beyond what we understand as of right now in math. So, I'm giving you this speech just because I don't want you taking it as, oh, this is just another extra math thing I have to do, and what's the point of this? So I'm going to show you how to do these by hand and with the calculator. I'm not sure if we will be testing this year how to do them by hand, but I know for a fact that next year you are going to be required to do these by hand. So might as well learn them. Plus, they're honestly pretty fun. So let's say we have matrix A, and the elements are A, B, C, and D. So this is just a general rule of how to find the determinant. So, and then after this, we're going to do a special case. I will show you the updated assignments, and I'm going to make another video on how to do 3x3 matrices by determinants of 3x3 matrices by hand. So to find the determinant of A, matrix A, all you're doing is you're going to take these two things and multiply them. So we're going to have A times B, A times D, and then you're going to subtract the product of the other two, B times C. And again, this is part of the reason why they call these a cross product in vector mathematics. So that's how you find it for a 2x2. For a 3x3, it's a little intense. Again, I'm going to show you that in another video. But this is all you have to do. So let's do an example. Now, here I want you to look at this. Notice how it says evaluate each determinant. Evaluate, because some of you still have trouble with really understanding what this word means. It just means find the value of the determinant, meaning you should get a numerical answer, meaning it should be a number. Notice how some of the problems, or actually all the problems here, are written in kind of like an absolute value type of thing. So when you see that on the homework, and I think I have a picture of the homework here. Let's see. Here we go. Oops. See, do you notice how a lot of these just have the absolute value and it just says solve? Don't worry about, these are like super challenging ones, but I guess they don't show them here yet. But a lot of these, here we go. Evaluate the determinant. And do you notice how they're all in absolute value? If you see a matrix in absolute value like this, it's not like they're in brackets like these. It's a very subtle difference. That means if you see them in absolute value, that means automatically you're finding the determinant. Okay? So you might either see, like when I said find the determinant of A, you might see it written this way, or you might see it written like that, or you might see it like this, obviously without the quotations. Okay, this line is bothering me. There you go. So you might any of these three directions all imply to find the determinant. Okay. All right. Let's do a practice problem real quick. And then I'm going to show you how to do that on the calculator. So let's see. We do 2 times 2, and then we're going to subtract -3 times 0. Okay. And that's just going to be 4. Let's see the answer. Yay. That's it. That's how you do it by hand. It's for 2x2 matrices. It's probably honestly easier to just do them by hand because they're so much quicker. Now let's talk about the special case. Okay. Now for this special case, it's a special case because we're going to have -9 times -2 minus 3 times 6. So we're going to have +18 minus +18, which ends up being 0. So now, even though the determinant is 0, and let me show you how to do this on the calculator. So I already have it as matrix B. I already have that put in. Yep, that's correct. Okay. So if your determinant is 0, that's going to determine that its inverse does not exist. Watch what happens. Oh, and to find the determinant, you can just go second matrix. When you go to math, it's the very, very first option. Det is determinant. So determinant of B is 0. That's all you need to do. That's how you do it on the calculator. So you would put it in under edit, and then go to math, determinant. So that's pretty straightforward. But now when the determinant is 0, that means that its inverse is not going to exist. What do I mean by that? Look at that. It's a singular matrix. What the heck is a singular matrix? So this is just a kind of cool special case. Now, if I change this to a system of equations, the inverse doesn't exist because these are basically the same exact equation. It's the same slope. This top equation is just 1.5 times bigger, or -1.5 times bigger than this one. So it's really the same equation, and it's either going to have, if you were to graph them, they would either overlap all the time or they would be parallel. So its inverse wouldn't exist. So if you have a determinant of 0, that's one of the many applications for determinants, is that it means that the inverse doesn't exist. And my -9 apparently decided to not exist anymore either. So that's it. That's all we got for 2x2 by hand and by the calculator. And then I'm going to upload a video on doing 3x3s by hand. Thanks for watching, guys.